Bismillahirrahmanirrahim. Today we are going to start the chapter dynamics and come to page number 118. The first topic that you will see is reference frame. Reference frame, okay? So reference, this is a word that you already are familiar with, right? Okay. Whenever I describe some position or the motion of something with respect to something, so we are using a reference frame, right? Okay. With respect to some reference, we were discussing the position of of a particular body or the velocity of a particular body. If you remember in grade 10, actually we already studied relative motion, relative rest, right? There actually we used a reference object, okay? Like when we said that these two bodies are in relative motion, it meant that with respect to a body, the other body is changing its position. So that time we can say that they are in relative motion. So one reference object has to be there. Achha. Let us go through the lines of the book, page number 118, okay? To describe the motion of a body, at first we have to choose a coordinate system or reference frame. Previously we chose a reference point. Now we are going to choose a reference frame, that is a coordinate system, okay? The reference frame is a rigid body with respect to which any point or object is specified at a particular place, right? Okay. A table, floor of a room, a road, a park, earth surface, the sun, or a galaxy may be considered as a reference frame. But this must always be definite. Yes. So they have given an example, okay? Let us say with respect to floor, I am trying to describe the position of a particular object, right? So the floor is being used as reference frame. How? Let us say I am telling you that this object is at a height of 32 meters. Now 32 meter, this is the height from where? From what? From the floor, right? So the floor has been used as a reference frame. Okay. Now a road can also be used as a reference frame. How? Let us say on the road there is a particular body and it moved a certain distance. Okay, so on the road we are considering the displacement, right? So the road is a reference frame. Acha. Likewise, a park is a location, and earth surface, this can be considered. Okay. Now there are three types of reference frame. One dimensional reference frame, like a road is a one dimensional reference frame, right? Okay. To express the displacement, you will give me actually only one dimension, right? Only one information is required. But the second type is two-dimensional. What is the difference between these two? Let us say the body was here and the body moved here. So to express the displacement, you have to give me two values. That how much distance I moved along x-axis and how much distance I moved along y-axis. Then I will be able to go from here to here, right? But in this case, to express the displacement, you have to give me only one value, 5 meter in this direction, right? But here, you have to give me two value. Let us say 5 and 2. Okay, that means you have to move 5 in the positive x direction and 2 in positive y direction. But in case it is -5, okay, let us say I am here now and from here I want to come here. Then what will happen? I have to come -5 direction, -5 distance. -5 means negative x direction. You have to move along negative x direction. This is the negative x direction, right? And this is the positive x direction. This is the positive y direction, and this is the negative y direction. So you from here, if you want to come here, you have to move -5, okay, and -2, right? So I hope this is clear that to describe any displacement in this particular coordinate system, what we are doing, we are having to give two information. So this is a two-dimensional coordinate system, x and y. Now the another one, that is three-dimensional coordinate system. I think you already got the idea of that. So in that you have to give me three information, x, y, z. how much we are moving along x-axis, how much along y-axis, and how much along z-axis. Okay, so let us go through this one-dimensional reference frame for our one-dimensional or linear motion. See, this can also be said a linear motion, right? Only the movement is along a straight line. That is why this is a linear motion. At first, a point on the straight line along which the body is moving is taken as origin, and one direction is taken as positive, right? There has to be an origin point. Let us say this is our origin point here. Okay, so from here actually we are moving right or left direction. Okay, just along this straight line. Okay, we cannot actually move in that direction, because whenever we move in something this direction, it becomes a two-dimensional coordinate system. Okay, so one direction is okay. One direction is taken to be positive, right? You have to mention actually which direction you are considering positive. If this direction is positive, then whenever the body is moving in this direction, you will say the displacement is plus 5 meter. And if it is moving in this direction, definitely that is the negative direction now. It will be minus 5 meter. Now, this straight line is named as either x, y, or z axis. Only one axis you have to mention, right? Okay. Generally, for one-dimensional reference frame, the axis is taken as x-axis. Yeah. Then we measure all other quantities with respect to this reference frame. Now let us talk about this two-dimensional reference frame. I already gave you the idea. Just let us clear up whatever there is written in the book. If a body moves in a plane, then its motion is called two-dimensional motion. Now this board is a two-dimensional plane, right? See, on the board, if I move a marker from here to here, then you see you have to tell me a direction along x-axis, then you have to tell me a direction that you moved along y-axis. This board is an example of two-dimensional reference frame. Okay. Now for describing two-dimensional motion, we need two axes or two-dimensional reference frame. In a two-dimensional place, a convenient point is chosen as origin, right? This is the origin, right? Okay. Whenever I'm saying that the location of this body is 3, 2, that means from origin, you have to move 3, then you have to move 2 along x and y axis, right? So with respect to origin, we describe the position of a body. Acha. And two mutually perpendicular straight lines are drawn through this point. Yes, we can see that this is the origin, and two mutually perpendicular line has been drawn here, which are known as x and y axis. The motion of an ant on a table or on a wall or a floor of a room is the example of two-dimensional motion, right? Okay. Now this table is also a two-dimensional system. Okay, because table is also a plane, two-dimensional plane, right? So a wall is similar. This board is like a wall, so this is also similar. Now let us see three-dimensional reference frame. If a body moves in space, then its motion is for three-dimensional motion. I already told you that we can consider the system of the corner of the room. If you look at the corner of your room, you will see that three axes are there. One is this direction, another one is in this direction, and another one is perpendicular. Did you all understand this example of the corner of a room whenever I talk about this three-dimensional coordinate system?
Yes.
Okay. So wherever you are standing, or if you hold this marker at this point, from that origin, if you want to come to this point, you will have to move in along three axes, right? You have to move a certain distance along x, certain distance along y, and then you have to move certain distance along z axis. Okay. Achha. For describing three-dimensional motion, we need three axes or three-dimensional reference frame. In a three-dimensional place, a convenient point is chosen as origin. Yeah, the 0, 0, 0 point is the origin one. Okay, just the corner of the room, that is the origin. In a three-dimensional place, a convenient and three mutually perpendicular straight lines are drawn. You will see the three axes that you are considering, they all are in 90-degree angle with each other. They all are at right angle. Okay. Achha. These three straight lines are considered as x, y, and z axis. The motion of a flying bird are an example of three-dimensional motion. Yes, a flying bird is moving in this space. Anything that is moving in this space is known as, um, you know, it is moving in a three-dimensional reference frame. But if an ant is moving on the wall, see, the wall is a two-dimensional system. Why? Because whenever we talk about a wall, we are not actually considering any movement along a particular direction. See, if you consider this direction to be, let me try to show it three-dimensionally on the board, but I don't know how much I can show you. I'm very bad at drawing, but let me try. So if this is our system, you will notice that this is a wall, right? This side is a wall, okay? And this side is another wall. And this is the floor, okay? This is the floor, how I can show, okay? Okay, you can at least imagine, right? This is the corner of your room. See the corner of your room, and from this corner, two walls has come out, okay? So if any ant is walking in on the wall, then it is, if this is x and if this is y, then it is walking on the xy plane. This is the xy plane. If this is z-axis, then the floor, it is the xz plane. And if anything is moving on this wall, then it is moving in yz plane. See, these two are consisting this plane, so this is in the yz plane. But if anything is not on the wall, but rather in the space, then you can actually, then you have to mention actually three dimension. So whenever a body is moving on the wall, what is happening? You can actually give me only two information. The movement along x-axis, the movement along y-axis. There is no movement along z-axis, right? There is no movement along there. আমার নিজের কাছে আসলে আমার মনে হচ্ছে না আমি কিছু আঁকতে পারছি, জানি না তোমরা কি বুঝতে পারছো? জাস্ট আইডিয়া।
বুঝতেছি।
আচ্ছা, ওকে ওকে। আবির, তুমি বুঝতে পারছো?
Yes, sir.
আচ্ছা, ওকে, গুড। ভেক্টর চ্যাপ্টারে কোনো ডাউট হলে কিন্তু জিজ্ঞেস করিও, ওকে? আমাকে মেসেজ করিও যে এটা সমস্যা।
Okay, sir.
আচ্ছা, so three-dimensional system, I hope you got a good idea about this reference frame, right? Okay. Now inertial and non-inertial reference frame, okay? So if this reference frame is rigid, it is not moving, okay, then what we can say, this is a inertial reference frame, right? Or if it is moving at a constant velocity, right, with each other, like Acha, I will explain. Let us go through the lines of the book first. Okay, inertial internal frame. Internal frame, let's say. এটা inertial frame হবে। Inertial internal frame না, এই টপিকটা এখানে আমি জানি না, আমার এখানে এটা দেয়া, তোমাদের বইতে কি inertial frame লেখা?
না, ইন্টারনাল, প্রথমে ইন্টারনাল পরে ইনার্শিয়াল।
ওই inertial frame হবে, যাই হোক। I don't know, maybe mistake. Acha, inertial reference frame is also known as Galilean reference frame, important for MCQ, or Newtonian reference frame. The second and third laws of motion of Newton suit very well in this reference frame. Already we know the laws of motion, right? Three laws of motion we already studied. Every object will continue to be at rest or at motion until a force is applied on it. Okay. Our second law কি ছিল? The rate of change of momentum of a body is directly proportional to the applied force, and the direction of this change occurs in the direction of the applied force. And the third one is the most popular and the easiest one, right? Every action has an equal and opposite reaction. So the second and third law of motion of Newton suit very well in this reference frame. In other words, it can be said that inertial reference frame is that reference frame where Newton's law of motion can be obtained. In case you forget the original definition of this inertial reference frame, you can just write this information, okay? If it is coming for 1 mark, if you write this at least, I think you will get that 1 mark, okay? Because this is the most important point. That is, the Newton's law can be applied in this frame, okay? So the frame where we can apply the Newton's law, that can be said as inertial frame, okay? These reference frame move with constant velocity with respect to each other. That is, definition, if you see the definition, the reference frame which are moving with constant velocity with respect to each other and where Newton's law of motion can be obtained are called inertial reference frame. Achha, the non-inertial one is the reference frame which are not moving with constant velocity with respect to each other. That is, the reference frame which have acceleration are called non-inertial frame. Okay, that means if this reference frame is still, the velocity is 0, inertial reference frame. Again, if it is moving with constant velocity, okay, if it is moving with constant velocity. Now let us say the corner point of our room or the three-dimensional system at the corner of our room, that can be considered an inertial reference frame because the velocity of it is 0. What is the velocity? That is not actually to be considered. What is to be considered is the changing of velocity. Is there is any change of velocity? No, the velocity is always 0, so it's constant velocity, so I can consider this one as inertial reference frame. Then again, let us think um, a car is moving, okay? Now the corner of a car, that is also a three-dimensional reference system, a three-dimensional system, right? So that if the car is moving at a constant velocity, then that corner of the car is also moving at constant velocity. Then also we can say that this is an inertial reference frame. But in case the car is not moving at a constant velocity, sometimes the speed is increasing, sometimes decreasing, that means the change of velocity is there, or should I say the acceleration is there, okay? So that time we will say this is non-inertial reference frame, okay? Now in non-inertial reference frame, it is very much hard to actually apply the Newton's law. Why it is not possible, we will discuss further in later classes, okay? Inshallah. As I can see, we have only 1 minute time left, so I would like to request you to go through the next topic, that is absolute motion and absolute rest. This is something we already talked about in grade 10, if you remember, okay? So we know that no object in this universe is at absolute motion or at absolute rest. Why it is that? If you forgot, I would like to request you to go through this part. Morshed, you are too early for the next class. Okay, so kindly go through this absolute motion and absolute rest, and then you have this relative motion. Come to page number 120 and 121. If you take a look, the position vector, displacement, velocity and speed, these things are something that we already know about, right? So go through the definition and try to understand the explanation. In the explanation, there might be some equations which are unfamiliar to you. So we will discuss about that in the following classes, inshallah. Okay. Thank you very much for joining. Anybody wants to ask any question before we end the class? Nobody? Okay. Thank you very much for joining. Assalamu alaikum wa rahmatullah wa barakatuh.